Hey everyone, in theory, we're live. Welcome to another regular episode of the, no, I don't want to save that as my password, Google. Oh, I should change that over there. Of the Open Space, which is just my live QA, just hanging out with you, answering your questions about space and astronomy, sometimes with guests, sometimes not. In a mirror universe, I would be in Tokyo right now, and this episode of Open Space would have been canceled, but I am not, and that's because of the stupid coronavirus. And so, as you know, last week decided not to go to Japan, and so instead I'm sticking around. I have no travel plans for a long time, I think, at this point. We're thinking of like maybe alternatively going and taking a trip to the US, Washington, Oregon, but now that looks like a terrible idea too. So I think we're just going to hunker down and do non-travel things. Yeah, that's the plan. So anyway, it's funny if you look back at the most recent episode that we did all about the Artemis mission and all of these people saying, very derisively, like, ha ha, stupid NASA. They're not going to be, they're going to be still in 2024 when the Starship is going to arrive in 2022 and just set up hotels, and won't that be hilarious? And of course, yesterday we just learned that the second Starship prototype just exploded. So that's two Starship prototypes exploding. Not to say that Starship isn't a game changer, not to say that it's not going to be the most incredible new paradigm for space exploration. It's just that these things are harder than you think. And that the Falcon Heavy took like almost a decade longer to blast off than anyone was ever anticipating. And here we are, and two Starships now have failed. And like here's for the third prototype. Let's see how that one does. It's definitely looking like an orbital flight is not going to happen as soon as anyone is expecting, which means that maybe other parts of the mission, like a mission to the moon or maybe Mars, that future Mars city, is going to need to get pushed back. And you need to be okay with maybe that Starship arriving at the moon after NASA does, or after the Chinese do. And maybe the Mars city won't happen until maybe like 2028, right? Be patient. So, anyway, I think it's kind of ironic, I think, to see all of the snippy comments made to the Artemis mission. And then here we are. You know what? Spaceflight is hard for everybody all the time. Don't ever take anything for granted. So I think it's a valuable life lesson for everybody. So anyway, go ahead and hit me with any of your questions that you've got, and we'll get cracking on them. I got an hour here. My time is your time. It's free, this bonus episode. One other quick little piece of news. We've got Phil Metzger, who wasn't able to make it last week because he was sick. He's rescheduled. Now it's March 23rd. So once again, we've got coming up, we've got Rob Hoyt from Tethers Unlimited. We've got Jim Al-Khalifi. We've got Ryan Watkins. We've got, and then Phil Metzger and other guests as well. So my hope is that actually we're going to have a run of a whole bunch of guests at weird times, but still guests. So there'll be less of me just yapping and more of the guests, but still. And then one other piece of information, our episode on the Phobos mission is coming out tomorrow, so stay tuned for that. All right, hit me with your questions. Let's do it. Arjone asks, why is everybody expecting to come so fast? We're talking about Elonian time here. Yeah, I mean, we make this joke on the Weekly Space Hangout about this idea of just like Elon Musk time, that whatever time Musk says, you just double and add 10, right? Whatever that number is in terms of months, terms of years, whatever it is. And in fact, someone has actually done a calculator to almost precisely predict when events will actually happen according to Elon Musk's comments. And the reality is that Elon Musk and SpaceX and Tesla, they're actually getting a lot more accurate more recently. So when you look at, say, the launch of the new Model Y, that's actually coming ahead of schedule. So they're getting a lot better at managing expectations. But the one that I think is, it's going to be a real challenge is Starship. So I do think it's funny that, am I the only person who's noticed these things take a little longer than Elon Musk thinks? Right? This can't be a surprise to you that it's going to take extra couple of years. And so just like bake that into your expectations for what's going to happen. And you won't be disappointed. But give them time. It's going to be amazing. All right. Ben Kalo, has NASA revealed any specific lunar surface mission objectives yet? Collect more rocks, hit golf balls, grow potatoes. No. Right now, there have been a bunch of new requests for proposals sent out from NASA for people to provide various science payloads and rovers and landers and things like that. There's actually like a whole bunch of, I'm actually thinking of doing like a separate episode just about just all of the stuff that's going to get hurled at the moon in the next couple of years, really. There's commercial payloads like the Astrobotic mission. There's going to be possibly a Blue Moon lander is going to go a little earlier, and there's going to be a bunch of really interesting various payloads. And the goal here really is to characterize how much water ice there is at the moon's south pole, because sort of the whole plan for space exploration for the future is really depending and hoping on everything that that they'll be able to accomplish if they can find local quantities of water at the moon's south pole. And so you can imagine that they're going to be drilling in, they're going to be bringing back samples of the regolith. They're going to be performing all kinds of experiments. And eventually, over the long term, leading up to sending some kind of fuel system, fuel reactor to the moon, digging into the regolith, pulling it all to one place, boiling out the water, splitting the water into hydrogen and oxygen, and then using that as a propellant to get back. And there's a pile of, like when Phil Metzger comes on, we're going to talk a ton about this process, about the machines they're designing to try to extract various valuable resources out of the lunar regolith. So this is right now the place that is most interesting. But I mean, the reality is that there's a ton of really interesting places on the moon. And my thoughts are always, right, that you try to not confuse your science with your exploration, with your human exploration. That the purpose of human exploration is to explore with humans. It's just to send humans farther and farther out into the solar system and make them survive in more difficult situations, longer periods, microgravity, maybe small amounts of gravity, harsh radiation, for different kind, to try to live off the land, like to just keep pushing the boundaries. And that's the only goal. Right? And so if you try to say, well, the reason why we're going to send humans back to the moon is that we're going to be able to get some science done, the reality is that robots do the science so much better. And so it's never, in my opinion, a good justification for for why you send humans into space. The reason to send humans into space is to learn how to send humans into space. That's the beginning and the end of the justification for why we do human exploration. And when you are able to do that and able to focus on that, then you can sort of have this really deep understanding of what it is that you're looking to get out of it. You're just looking to get better at sending humans into space. And all of the science that goes along with that will keep you busy forever. So it's worth it. Arjun asks, how long have I been running Universe Today? Yeah, I've been running Universe Today since March 1999. So we are now just shy of 21 years now that I've been doing the job of running Universe Today. And for people who don't know, right, my background is in computer science. I've always been interested in amateur astronomy. As a kid, as a teenager, I was on the journalism program at my high school, and I wrote articles about space and astronomy for my newspaper, for my school newspaper, which was hilarious. And then I went into engineering at the University of British Columbia, and then left that to go start a software company with a friend of mine. And then left that to go join another software company and work there. And then as a sort of a part-time gig, started doing Universe Today on the side, just because I really enjoyed space and astronomy, and I wanted to wrap my head around it a little better. And so I just started maintaining the website on the side, and within a couple of months, I just realized, right, like this is all I ever want to do with my life. And then it's just a matter of how do I organize everything so that I can just focus on doing Universe Today full time. And it probably took me, so from when I first started Universe Today, and you can always go back and look on the Wayback Machine to like all the way back to some of the first articles that I ever did. It was really more like a synopsis of the big news that was happening. And then over time, I started to write my own original articles. And then I started to bring on other journalists to work with me. And since then, podcasts, articles, videos, etc., all of that. And like I said, just shy of 21 years now of doing this job. So overnight success, all you have to do is just work on something for about 20 years to feel like you're doing a good job of it. And at this point, I still have a ton to learn. So I'll check back in another 20 years or so. Alpha Orionis 911. Fraser, do you think that Starship went higher than SLS will ever do? Oh, that's so mean. So of course, Starship has gone high a couple of times, right? There's of course the original Starhopper test that went well. Then there was one explosion where it blew its top very high. Then the test that happened yesterday, I haven't sort of looked into all the details, but the gist is it exploded off of the launch pad a little bit. So it kind of flew. And then of course that's saying, well, is that higher than SLS? No, SLS is absolutely going to launch. There is no way that rocket will not launch. We will see at least one space launch system launch. I would anticipate 4 before Starship gets flying, demonstrates that it's clearly the better system, and space launch system gets canceled. That's my guess, but we'll find out what's actually going to happen in reality. For some of the ambitious missions that are out there, there is only space launch system, right? If you want to send humans to the moon right now, today, there is nothing but the space launch system. And of course that doesn't exist, but the first one should be launching like next year. So we are very close to that first space launch system launch, while Starship is still, I would say still 4, 5, 6 years away from successfully proving all the parts and becoming human rated and all of that stuff, right? And there's probably going to be 4 or 5 launches of SLS in between then. So yeah, I think we're, but still, that's brutal takedown. Alpha Orionis, Fraser, Kirk or Picard? Picard. And the new Picard show is good. I'm really enjoying it. Especially, I gotta say, seeing all of the older characters that are coming back and making their cameos in kind of appropriate ways. So so far, I'm really I'm really enjoying Picard. I mean, it's yeah. I hope it maintains it. Although I've been liking all of them. I mean, I've been liking the new, oh man, what's the other Star Trek? Discovery? I've been liking that. So yeah. Let's see. Apologies. I'm looking for another question here. the bee's nest. Is there zero gravity in open stellar space? So I guess the question that you're asking is that if you were far enough away from the Milky Way or far enough away from the sun, will you have zero gravity? And the answer is no. In fact, you are being influenced by the gravity of every single molecule, every single atom in the entire observable universe right now. In other words, if you can see it, you're experiencing gravity from it. You're experiencing gravity from that star up in the sky. You're experiencing gravity from Mars. You're experiencing gravity from the very farthest particles that are just before the cosmic microwave background radiation. It's just that you're experiencing different amounts of gravity. You're experiencing the most gravity from the Earth, and then you're experiencing less gravity from the sun, and then you're experiencing less gravity from Mars, and so on and so forth. But the thing is that when you're out in space and you are floating around and you feel like you have no gravity, you're actually just in balance. So you are experiencing equal amounts of forces, balanced forces on your body at the time, which is making you feel like you have no gravity. But really you're free falling, right? So imagine you know that feeling when you jump off of like a really high diving board and you fall into the water, and you have that feeling of free fall that kind of, it's very unnerving, right? It's fun, but it's also like a little scary. That's the feeling that you get while you're in space, because you're constantly falling. And so when the astronauts are going around the Earth, they are falling. It's just that they keep missing the Earth as they go around and around the Earth. And the same thing will be happening, right? If you go out into the middle of space in between two stars, you are being accelerated towards something, right? Some star around, or you're in orbit around the Milky Way, just like all the other stars. And so you are not feeling any forces, but you are falling around the core of the Milky Way, just like all the other stars. And so the feeling would be the same. It's not like when you go underwater and you swim around underwater, you're still feeling gravity. All your internal organs, you're still feeling this same familiar force of gravity, like when you're just sitting in a seat. It's that feeling of falling. So that's why a lot of astronauts vomit. Drones and bones. Should we bump up next generation telescope ideas since we found out how common planets are? I don't think that you want to. Okay, so there are plenty of next generation telescope ideas that are in the works right now. You've got all of the gigantic super telescopes that are coming here on Earth, right? You've got the extremely large telescope, you've got the Magellan telescope, you've got the 30-meter telescope, maybe, which are in the plans right now. And each one of those is going to just be enormous compared to any telescope that's ever existed. The extremely large telescope will be capable of observing planets orbiting other stars. It's going to be able to calculate the radial velocity of planets orbiting around other stars. So James Webb, etc. WFIRST. So there's a bunch of these missions that are already in the works. And then right now, astronomers from in the US and the international community are working on their next generation telescopes. And this is where you've got LUVOIR and LYNX and Origins and HabEx. So you got 4 more mega telescopes, which are the ones that come after James Webb. And those are all in the plans right now. Should we be planning telescopes that come after them? No, right? We wait for the next decadal survey. So the decadal survey is happening right now, the 2020, and then you're waiting for the 2030 decadal survey, which is going to be happening in 10 years. And then we'll find out what the next generation of mega telescopes are going to be. And even what has survived that decade-long process of winnowing down. Will all 4 telescopes launch? Will only one? We don't know yet. We'll have to find out. Oh, Plastic Pinocchio. Any words on the death of Mr. Dyson? I think it would be kind to remember him. Yeah, so for people who don't know, we lost one of our sort of most famous engineers, the one that that, of course, we are all so fascinated about here when we think about the future of astronomy, and that's Freeman Dyson. I think he was like 86 years old, so he had a pretty good life. But I think people are really kind of surprised that he was still alive as we were describing and discussing his ideas, his famous ideas about how future civilizations might end up using all of the power coming from their star. But obviously he was more than an astronomer, although he was a very skilled astronomer, mathematician, physicist, and quite active. And I never met him. I met his sister, Esther Dyson, but I never met Freeman Dyson. But I've heard some conversations about he was a very active letter writer, correspondent, and sort of continued having very fascinating, interesting conversations right until sort of the end of his life. And so, I mean, thank you for just giving us these ideas of helping our imagination soar. And I think that we've all been made better by being able to have those thoughts. Maybe I'll do an episode and sort of look back into the history. So, but that's, I don't have any more information to say about that right now, just because I don't really know. Oh, there you go. He was 92. There you go. So, yeah. F-Zero, would you rather go to Titan, Enceladus, or Europa? Is it really possible ice shell moons could have the simple life? Of those three choices, I would absolutely choose to go to Titan. Like, if you're acting like personally, I would prefer to go to Titan personally, obviously because it's got a thick atmosphere and low gravity, and you could strap on a pair of wings and you could fly around, which I'm sure you've all heard this idea, which would be amazing, right? And then of course you've got mountains made of ice. You've got oceans made of liquid methane. It rains. So it would be a very familiar yet very bizarre world. While Europa and Enceladus would be kind of like trying to walk around on those like some big glacier with enormous chasms and cracks and stuff. It would be cool, but it would be kind of the same all the time. So I think if I had to pick one of those places, I would like to go to Titan. And I think if I could pick a spacecraft, I can't choose one. I'm going to choose two. I'm going to choose Titan and Europa. So if I had to choose two, I'd go to Titan and Europa, and then Enceladus would come after. Even though Enceladus is kind of interesting too. Don't make me choose. Bill Sugden, you mentioned WFIRST, but the latest NASA budget has zero funding. I didn't know, I haven't heard the state of the House of Congress. So typically, every year, the White House tries to cancel WFIRST. And every year, Congress puts the funding back. So I don't know if, so right now, if it's the White House budget is wish list. It's like a letter to Santa Claus. And it rarely survives the actual process of going through the government. And so I doubt WFIRST will actually get canceled. But unless there's like some piece of news that I'm not aware of. Mike McHugh, any thoughts on Mad Mike Hughes, the steam rocket guy? Yeah, so people heard this guy tested his steam-powered rocket. He was intending to, I think he was going to fire his rocket, and then he was going to go on a balloon higher. Yeah, that sucks. It's awful to see somebody die. And to be, obviously it's incredibly dangerous, and it shows how complicated and how difficult these are and how important safety is. So, for his friends and family, I think it's a tragedy. And I hope other people who are attempting these kinds of experiments on their own just consider how dangerous a process this is, and they work out some kind of safety mechanisms. So, Mr. Hand, why should AI not kill us? Wow. Oh man. Well, I did a whole episode on existential threats and talked quite a bit about the idea of artificial intelligence, and I am definitely in the artificial intelligence is a danger that we should be very, very concerned about. It is bringing into being a power that we have no idea what the long-term consequences of it are going to be. And and anyone who tells you that they do doesn't, because it's never happened before in the history of humanity. And we have definitely seen computers do things badly quickly, right? Like we've seen computers crash the stock market, and we've seen computers, all kinds of very serious bugs. We saw what happened with some of the Boeing 737 crashes, that potentially there was computer issues involved. So people who have died with autopilot. So it doesn't seem super, as we watch the power of computing double every 18 months to 2 years right now, you just keep doubling. And after a while, exponential power just catches up. And we're able to do things now with artificial intelligence that are kind of amazing, right? That I can speak to my computer and it understands, or it can translate the words that I'm saying into another language. It can recognize images and know what's a cat and what's not a cat, and it can draw people that don't exist, and deep fakes, and so on and so forth, right? And it can play StarCraft at an elite level, and it can play Dota. And so you can just imagine everything that we thought humans could once do, eventually artificial intelligence will do. And then you, of course, have to wonder, where does this end? And then the part that does sort of concern me is that right now, today, we've got, to do a really powerful artificial intelligence is going to require just the capabilities of a nation, of China or the United States, maybe Canada, to be able to actually create something that's very powerful. But eventually it's going to be a research institution. It's going to be a university. It's going to be a company, a very big company. And then eventually, right, just double, right? Just keep doubling. Eventually it's going to be a small team of elite programmers. And then eventually it's going to be one person. And then it's going to be a script kiddie can release a very powerful, very devastating artificial intelligence. Now, the one thing that I kind of do like is this idea of, the Fermi paradox. And we think about these things that might wipe us out. We don't see alien robots, right? We don't see artificial intelligences attempting to settle and dominate the entire Milky Way. And so it feels like whatever has made it that there aren't other alien civilizations out there, it's not because their artificial intelligences ran away and colonized the entire Milky Way. And so that's like a silver lining to the cloud. But I'm super, I wouldn't say I'm panicked, but I am definitely alert to the possible repercussions of artificial intelligence. And, in the very best case scenario, it causes all kinds of problems in employment and in, the power of surveillance that people have over each other. Like, just the absolute best case is that you've essentially got the power of God at your disposal. And some people will have it and other people won't. That's your best case scenario. And your worst case scenario is that gets out of your control. So I think there are some very smart people who are concerned and have some very valid suggestions on how we can try to consider what the implications are. And I think a lot of that stuff we should be working on. So, Optimus Narkill. What to you would be a dead giveaway of life on another planet or somewhere out there in space besides a dead giveaway like techno-signatures? And what are, in your mind, the chances that we find any? Well, the dead giveaways would be the techno-signatures. So the thing that would be the absolute most obvious that would tell us, okay, there is no question that there is an intelligent civilization on some other star system, or life. The thing that would tell you that there's life on another star system is some kind of techno-signature. In other words, if you were receiving some kind of radio signal from another star system that was in a frequency that you just can't find in nature, that was repeating in a way that you wouldn't see in nature, then you would know for certain that there is an intelligent civilization there. If you did a transit, if you were observing the transits of some other star system and you saw shapes passing in front of the star, triangles, right? Snowflakes, things that we don't have, that don't exist naturally in space. TIE fighters, right? Death Stars would look like a planet. So then you would know that someone built that. And then that would tell you that there was intelligent life there, and then that would tell you that there was life there. So right now, when it comes to just of trying to observe life on another star system, this idea of just biosignatures. And it turns out that finding biosignatures is going to be really, really tough. For every smoking gun that astronomers think might tell us that there's life on some other planet, other people are figuring out natural ways that those things could arrive. Oxygen, ozone, methane in the atmosphere, water, all these things. It turns out there's natural processes that can make them happen. So it really does seem like that without that technosignature confirming that there's life is going to require a lot of just confirmation and more data and more evidence, and it's going to be this big case. So think about how difficult it is to prove that there's life on Mars, and Mars is just right there. That's how difficult it's going to be to prove that there's life on another planet around another star system. If you found a fossil on Mars, you'd know there was life there, but it hasn't been that easy. Aaron's, how does NASA know how much fuel is left on a spacecraft like Voyager 1 and 2? They say that they will last till the next decade. So there's actually two different kinds of fuel that are on many spacecraft out there that are in the outer solar system. So the first kind of fuel is propellant. And that's, of course, what you see when a rocket takes off, right, is propellant. And so after a rocket launches from the Earth and it goes on its cruise phase to some other planet, some other part of the solar system, it still has rockets on board and fuel reserves, propellant reserves, so that it can fire that propellant to be able to go into orbit or change its orientation or be able to go onto a new course. And so a good example of that is like New Horizons, right? New Horizons flew from the Earth, did a course correction at Jupiter, made it out to Pluto, then fired its engine to make a new course to be able to get to, I can't remember, Arakash, the new MU 2019. And then it, having done that flyby, is then going to do another, hopefully, flyby of some other object. And so it's got like a little bit of fuel left. It's got enough fuel that you can imagine there's like a cone in front of New Horizons, a possibility cone, and it could fire its thrusters and make it to some other object and be able to do a flyby. So that's the one kind of fuel that it has on board, propellant. The other kind of fuel that it has on board is the one that it uses for electricity. And so it's actually got these pellets of plutonium on board. And the plutonium is constantly sort of decaying and giving off a tremendous amount of heat as it decays. And then it's got this thermocouple. It's got this sort of machine around it that is extracting the heat and using that for electricity. And it's kind of incredible how long this lasts. So like they've lasted for 40 plus years. And over time, every year that goes by, these nuclear batteries are giving off less and less energy, and the engineers working with the Voyagers have already had to turn off a bunch of the instruments on board, and they'll have to, like, if they want to make Voyager do something, they have to turn off a whole bunch of switches, and then they turn on the one instrument that they want, and then they perform that science, and then they turn off the science instrument again, and then they transmit the data back, right? And then they turn off that, right, because they're running out of power. And you can think about it like, your house only has a little bit of power and you have to manage what you've got. And then eventually the power levels will get so low that they just can't turn anything on. They can't transmit, they can't turn any of their science instruments on, and then that's the end. And that's when the Voyagers will finally be lost to us, because we just can't communicate with them. We can't tell them what to do. They can't run any of their experiments, and then they're just out. So to keep that in mind, on, say, Curiosity has that same kind of battery on it. The Mars 2020 rover, Cassini had that kind of a battery. The Voyagers, New Horizons, the Pioneers. While, say, spacecraft that are closer to the sun, the stuff that's around Mars, even the Juno spacecraft, they're using solar panels. So their solar panels will essentially, theoretically, never run out of electricity, right? They're just, as long as the sun is shining, as long as their panels still work, they'll be able to keep getting electricity. But, say, Juno will eventually run out of propellant to maintain the orbits that they want it to be on. And so, like the other spacecraft, they will crash Juno into Jupiter to prevent it from possibly crashing into Europa at some point in the distant future. So you always got to imagine, you've got the propellant for maneuvering, and then you've got your whatever is your energy source for providing your electricity, and you have to deal with both of those. Yeah, someone's mentioning that Dragonfly will too. Yeah, so the helicopter drone that's going to Titan is going to have one of these nuclear batteries on board, and so it'll be able to fly around as long as this battery lasts. And we're looking at decades, which is kind of amazing, right? That we're still going to keep hearing about this helicopter flying around on Titan for decades, which is pretty exciting. A59X, how do we know that we are 100% bound to collide with Andromeda? So astronomers measure the velocity of various objects in space according to the Doppler shift, the change of the light. So when things are moving towards us, their light shifts a little bit to the blue. And when things are moving away from us, the light shifts a little bit to the red. And so if you observe something, some object that you know should be a certain color, like a galaxy, right? And you measure the wavelength of the light, and you see that in fact everything is shifted a little bit to the blue, that means that it is moving on a trajectory that brings it towards you. And from there, you can actually calculate its actual exact trajectory, or its rough trajectory, and see that that trajectory is going to interact with the Milky Way at some point in the future. And of course, the reason why Andromeda and the Milky Way are moving towards each other is because they are gravitationally bound to each other. At some point in the future, they will begin this process of merging, where they sort of, tear each other apart and then eventually merge into one big galaxy. And the same thing, we can look it out and see all of the dwarf galaxies. We can see that the Triangulum galaxy is moving towards us. And so whatever is moving towards us right now will eventually become part of this new super galaxy once everything is said and done, tens of billions of years from now. Richard Grace, what's your favorite deep space object? Have you tried to image it? I would say my favorite, I've got a bunch, right? So I would say my favorite planet is Saturn. It's just like Saturn is the one that turns a person into a believer. It's a way to check if a person is like just dead inside. Have them look through a telescope at Saturn. And if they're not just blown away and say, whoa, then you know that they might be like a clone, or, that they're an artificial intelligence. So that Saturn is the best. I love globular clusters, especially the one that's in Hercules. It's one of these ones that is big enough and bright enough that you can just see it with a pair of binoculars, a small telescope. It's very easy to find. It's in a place that's really easy to find. And so I will often say, I've taught so many people how to find that globular cluster. It's just so pretty. And then when you actually photograph, it's so easy to photograph, and it's just this beautiful buzzing ball of stars. And then when it comes to fainter nebula, I really like the Rosette Nebula, which looks like its name. It looks like this gigantic rose. It's huge. It's as big as the field of view of a very wide telescope, and has this beautiful structure in it. And of course, there's if you do a search for Fraser, Cain, virtual star party, there's a whole video all about me oohing and ahhing over the Rosette Nebula. So definitely check that out. Apologies. I'm looking for another question. ACOG Main. Could a Dyson Sphere around a black hole stop the heat death? Wow, you just merged 3 mind-bending concepts into just one question, which I love. So if you put a Dyson Sphere around a black hole, would that stop the heat death? No, nothing stops the heat death. There's no way to prevent the heat death. Of course, the heat death is the inevitable distant future when all the usable energy in the universe is used up, and essentially there is no way to get any more energy out. And it's going to be a long, long time, right? And you can imagine in some far, far future, yeah, you could put your Dyson Sphere around your black hole, and then you drop matter into the black hole, and thanks to this process called the Penrose process, you can extract about 59%, I think that's the number, maybe it's 39, anyway, some appreciable amount of the matter that you drop into your black hole gets spewed back out in the form of gamma radiation, which you catch, and then you use for, I don't know, powering your superpowered computers. But then eventually you're going to run out of matter. You fed it all into the black hole, and then it's all come back out, and then everything is cooled down. And then the black hole evaporates. And then maybe the protons that make up your Dyson Sphere decay. So there's no getting around the heat death of the universe. And your second question here, can we ever find out what the Great Attractor is? We know what the Great Attractor is. The Great Attractor is a bunch of galaxies. So you may want to update your looking into this, but essentially, for people who don't know, right, the Great Attractor, for the longest time, right, we looked into the core of the Milky Way and we couldn't see what's on the other side of it because there is gas and dust that are just completely blocking this region. And so astronomers would call this the zone of avoidance. Don't look into the zone of avoidance, not because it's bad, but just because it's obscured, right? If you're gonna look out your front window, don't look at your wall. Use the window, not the wall. So, same thing. If you're gonna look out across the universe, use places that aren't covered by gas and dust. And so, astronomers, as they did that, found this really weird situation that it seemed like, again, back to that Doppler shift that we mentioned earlier, that all of these galaxies seem to be sliding towards something. But that something happened to be on the far side of the Milky Way core. And so just like bad luck, we couldn't see what this was. And the assumption was that it was a whole bunch of galaxies, right? That if you've got a great big supercluster of galaxies and you're on one side of that supercluster of galaxies, you can see everything falling towards this galaxy. But now with the development of infrared astronomy, astronomers and radio astronomy, astronomers are able to see in wavelengths that do look right through the gas and dust that obscures the Milky Way. And so when astronomers did that, when they turned their infrared observatories and their radio observatories on this region, they saw a whole lot of galaxies. So a big galaxy cluster. And so it turns out that all the Great Attractor is a lot of galaxies that happen to be on the far side of the Milky Way, and all of these galaxies are falling towards it. And that's all the Great Attractor is. It's nothing spooky or scary. It's just that, it's an overdensity of galaxies in one direction. Alpha Rhinus 911. Fraser, will I be going Nova this year? I don't know. You tell me. Aaron's. I heard that the Navy built a laser weapon on their ship. Would it theoretically work in space to deflect an asteroid? Yeah, there's been some really great ideas in using lasers to deflect asteroids. And the thinking goes that you fire a laser at an asteroid or a piece of space junk or whatever, and you vaporize a little bit of the material on it. And when you do that, that material flies off of the asteroid or the piece of space junk and gives it a tiny little kick in the opposite direction. So it's almost like you're hitting it with a laser and you're turning a chunk of that asteroid into a tiny little thruster. And then you just keep doing it. Hit it again, hit it again, hit it again. And it slowly changes the orbit, the trajectory of this asteroid. The key to this is that you need a long time because the amount of every one of these thrusts is really small. And so you want decades of you having some laser that's constantly shooting, hey, 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 right? Changing the trajectory of that asteroid to the point that now it's going to miss Earth in the far, far future. With space junk, of course, the stuff's orbiting the Earth, and it's eventually going to make its way back down through the atmosphere. Same thing. You put a laser in space, fire at the space junk, slows it down, and it starts to move into the Earth's atmosphere more rapidly and burns up. And that's one of probably the best idea for how to get rid of space junk that anyone has come up with, because a laser can shoot in kind of any direction. So as the space junk goes by, it shoots it with the laser, slows it down a little bit. With all the other methods of trying to deal with space junk, you have to fly up and you have to go into essentially the same trajectory as the piece of space junk to catch it, right? Very expensive, very complicated. Imagine you wanted to catch a bullet that was flying by, and so you had to go and get into your SR-71 Blackbird, get your crew going, get up to full speed, fly beside the bullet, have some little Canadian-built arm reach out, grab the bullet, put it inside the airplane, fly back and land, and then do that again, right? For every little for every bullet that's ever been fired. That's what you'd have to do. So it's a very complicated task, and the lasers work. Of course, people putting a gigantic laser system in orbit is, problematic. You can imagine some security concerns from certain people. So, A59X, what are your thoughts on the idea that we live in a simulated reality? I did a whole video on the simulation hypothesis. My opinion is it's a cool idea and impossible to disprove. So, but it doesn't mean anything. You can't use it to give you any, it can't inform you on how to live your life. So every year that goes by that we make better and better simulations, it seems like the possibility grows that we are living in a simulation, but still, there's no way to know. Therefore, just got to live your life. F0, is Betelgeuse still dimming or stabilized? Yeah, it has stabilized and is starting to grow. And at this point now, it really is starting to be that it was the dust was causing it to dim so significantly, some kind of cloud of dust that was passing in between us and the star. So, but we will find out as it continues to brighten again over time. But get out there, use your eyes, you watch this happen. You can watch it grow brighter and brighter every night over the next few months. So, Optimus Narkill. Where is Andromeda's supermassive black hole? It's at the middle of Andromeda. So Andromeda has a supermassive black hole, just like the Milky Way has a supermassive black hole. And Andromeda's supermassive black hole is like 100 million times the mass of the sun. So it's much bigger. Ours is teeny tiny compared to that one. Orlando St. Sebastian, again, showing the influence of Big Canada Arm. Beware, people. Yeah, we have an article on Universe Today in the works right now. Canada just funded some new rover and nano rover technology for the moon. And of course, I want to try and find some rovers that are just made entirely of arms, right? Like, that's all it's going to be. Like, let's try something with 6 Canada arms. So the point is, as Canadians, we've never seen a spacecraft, rover, or anything that couldn't use a few extra robotic arms. Hey, on Twitch, Rigel16, in my opinion, in your opinion, is the universe infinite? We have no idea whether the universe is infinite, right? From what we can tell, the universe is still either finite or infinite. It's just that we can't tell which one it is. So it could be finite, but so big that the curvature of the universe is so small that we can't sense it, or it's infinite. And it might be that in the future we will be able to do better measurements to the point that we can determine if it is infinite or not. And it might be that we can never do it. That we will always say the universe is finite to some size, right? Like maybe the actual universe is 1,000, is 1,000,000,000,000 light years across. And that is the smallest possible size that we've been able to measure so far. But it might be bigger. I mean, we definitely are sure that the actual universe is bigger than the observable universe, but we don't know how big it is, and it might be infinite. And infinite is weird when you think about it, right? Like just an infinite universe is just a head scratcher. But then, I mean, like so much of physics and is a head scratcher, right? So it would fit right in with all of the other weirdness that we're discovering about the universe. Matt Potter, does it matter if the universe is finite or infinite? Not for our purposes, no. I mean, we just want to know the answer, right? Are you curious? Then the answer matters. If you're not curious, then the answer doesn't matter. But it doesn't really provide us any practical thing. Although, if we were able to determine for sure that the universe was infinite, then you would know that there was an infinite number of yous out there, right? That there would be an infinite number of Earths, an infinite number of Frasers giving a chat on YouTube all the time, forever. So that'd be weird, right? Weird. And no matter how bad you feel about something that went wrong in your life, you know that there's, an infinite number of yous out there that life is happening both worse and better. So an infinite number. Optimus Narkill, I read somewhere that they couldn't find Andromeda's black hole in the middle. No, you're talking about M33. You're talking about the galaxy in Triangulum. So astronomers can't find the supermassive black hole in Triangulum, but they can find the one in Andromeda. Animus Channel, I still think it's a long ways down the road to the chemist. Yes. Best quote ever. But you'll have no idea how mind-bogglingly big space is. Let's see. Anything else? Aaron's. What happened to MarsOne? It was huge a few years ago. Yeah, I think MarsOne is at this point totally done, bankrupt. They ran out of money, and I don't think they're going to be trying to send humans to Mars anymore. So I actually did an interview on the Weekly Space Hangout a couple of years ago with the director of MarsOne. So if you want to hear all of my questions, I was a little, I wasn't harsh, but I definitely asked some tough questions. So you may want to check that one out. I'm sure someone can find a link to that. I think my feeling with MarsOne was their intentions were always to do what they said they were going to do. I really never got the impression that they weren't planning to do. It's just that there's no money, right? There is no business case to be made for sending humans to Mars. So anyone who tries to do anything, even Elon Musk, is going to find that attempting to live on Mars, attempting to send humans to Mars, or even to space in any way, shape, or form, is just a giant hole that you dump money into and it just disappears. And the question is just how much money are you willing to dump into that hole until you run out of money? And so, and anyone who goes on after MarsOne is going to find out the same answer. Asteroid mining is not going to make it profitable. Helium mining on the moon is not going to make it profitable. Power in space is not going to make it profitable. It is just going to be a place where you just dump money, just like owning a boat. So MarsOne won't be the first, and they won't be the last. Until they're not. Until the infrastructure in space grows to the point that until we can live in space and someone can pull a profit from it. But that is a long, long time. Like decades, hundreds of years. So you need deep pockets. Unfortunately, you need the kind of resources that a government can bring to the table. Neil Yu, Fraser, dark energy is in doubt, right? Today, Dr. Sabina Hasselfelder had Dr. Sarkar on her YouTube. He said that dark energy observations are in doubt. There are some observations. I mean, I haven't seen her video yet, but I do recommend Sabina Hasselfelder's work. She's terrific. Very fascinating. She's skeptical and sort of more of a realist on what's happening in terms of particle accelerators and physics and things like that, and so the essentially the evidence that is building against dark energy, or the evidence for dark energy, is that there are all of these galaxies that are speeding away, and you measure the speed of these galaxies going away thanks to type 1a supernova, which are thought to explode at a very specific amount of energy. And this has been very well mapped out. And so astronomers look out and they see all these supernova, and they know how much energy they gave off when they exploded. And so by measuring the speed that they're moving away from us, you can tell how far away these galaxies are. And this was the big surprise, and Nobel Prizes for everybody. And so the new piece of research that came out this year is that it might be that what makes, like, essentially the chemical signature that a supernova, a type 1a supernova, gives off was different earlier in the universe than it is now. That essentially when the universe was younger, these type 1a supernova looked a little different than they do today, and that if you take that into account, dark energy goes away. Super interesting. If that's true and dark energy goes away, good. That makes life simpler, right? And if it turns out that it doesn't, good. The universe is weirder than we thought. And so I find it really strange that people think that scientists will have any problem with either way, right? Whatever is true allows you to learn more about the universe, and that's really exciting. And so I can't wait for it to be proven more true, that more energy to mount, more evidence to mount that dark energy is truly a thing, and we are able to measure it with higher and higher precision. And I can't wait for someone to realize and figure out the flaw and discover that dark energy is totally not a real thing, and the whole idea needs to be thrown in the garbage. What matters is truth. What matters is that we learn more about how the universe works, wherever it takes us, whatever the universe decides to reveal to us. And either way is exciting. And I can't wait to watch this journey unfold and all the different weird mysteries that we're getting a chance to watch right now together in real time. What is dark matter? What is dark energy? Where did the universe come from? Where will it go? All of these questions, we just don't know the answers to them yet, and we are watching as scientists figure this out, one answer at a time. So, all right, I've reached the end of my hour, and so I'm going to wrap things up. Again, we've got Rob Hoyt from Tethers Unlimited, which is going to be really cool, right? These are the people who are doing space-based manufacturing. That's going to be next week. And then I've got Jim Al-Khalifi, who is going to be on the show with me. We're going to talk for an hour. It's going to be a funny time, so put that in your calendar. We've got Ryan Watkins, who is a lunar scientist, joining me as well, and then of course we've got who else have I got? Jeff Metzger. So lots of good stuff coming. Stay tuned. And of course, all the other stuff. Tomorrow, Phobos episode, weekly space hangout, new astronomy cast on Friday. So stay tuned. All right. Thanks, everybody. We'll see you all next week.